In this new playlist, I'm gonna be talking about name entity recognition using different techniques and paradigms. For example, the classical approach, the traditional approach for name entity recognition is using these fine-tuning these pre-trained models such as BERT, BioBERT, and so on. So my focus in this lecture is on this paper in 2019. And the dataset for NER could be for disease. For example, we use BC5 CDR. For drug, we use I2B2. You should register for that to get the dataset. And for name entity recognition, we usually use these. For relation extraction, we can also use ChemProt. So each one of these models, like BioBERT, has different set of parameters. And you see the F1 accuracy for BioBERT is 91%. For example, for this dataset. But there are many datasets, so you can refer to this National Center for Biotechnology information to look at different datasets. And for pre-training, there are many approaches. For example, if you want to do BioBERT pre-training, you can use this technique, but mostly we want to focus on just use the pre-trained model and just fine-tune it for a specific task, such as name entity recognition or relation extraction or entity linking, anything. So now you use your pre-trained model to have a good representation. And you only need to import auto tokenizer. And for fine-tuning, you can use task-specific datasets. For example, as I said, NCBI dataset, this is for disease. Or for BioBERT fine-tuning, you can use the... So for example, for BioBERT disease, you can have these dataset. I2B2 is very popular. You see it in any article. NCBI. So these are very good data sets that you can validate and see if your model is working good or not, or does it outperform the state of the art or not. For example, for gene disease, you can use this data set. For protein chemical, you can use ChemProt. And you see the precision, recall, and F1 accuracy for each of these. So the traditional approach is token by token, but it has certain limitations that you will see why in future lectures. I will be talking about different methods, different paradigms, such as span-based methods, which are even good for nested name entities. So we use the BioBERT pre-trained model, for example, this model, and then we train it, we fine-tune it, and finally we validate it and do it for test as well. And this is a typical data set. For example, entity. For example, it is beginning or inside or even outside. So you can save and load your fine-tuned model, and for prediction, you just use your own fine-tuned model that you have trained.